Let us solve for x in this problem. 5 raised to power x times 5 raised to power x is equal to 30. So we have 5 raised to power x times 5 raised to power x is equal to 30. This is 5 raised to power x raised to power 2 is equal to 30. By law of indices, given a raised to power c raised to power m, you can open this bracket by simply multiplying the powers to give us a raised to power c times m. Then our equation becomes 5 raised to power x times 2 is 2x equal to 30. This is an exponential equation, so I'm going to take the logarithm of both sides of this equation. Log 5 raised to power 2x is equal to log 30. The expression on the left hand side is of the form log a raised to power c, and by law of logarithm, this is c times log a. So our equation becomes log, or 2x times log 5 is equal to log 30. I can divide both sides by log 5. So that log 5 cancels log 5 here, giving us 2x is equal to log 30 divided by log 5. Then we write this as 2x is equal to log 30 here is 5 times 6, then divided by log 5. I need to separate this product, and to do that, I'll apply this law of logarithm. Log m times p. By law of logarithm, this will give us log m plus log p. So we're going to have 2x is equal to log 5 plus log 6, then divided by log 5. I'm going to separate this division. This will give us 2x is equal to log 5 divided by log 5, then plus log 6 divided by log 5. Right here we see log 5 divided by log 5. This will give us 1. So we have 2x is equal to 1 plus log 6 here. I can also write this as log 2 times 3 and divided by log 5. So we have 2x is equal to 1 plus, again we separate this product, so we have log 2 plus log 3, both divided by log 5. We have 2x is equal to 1 plus log 2 divided by log 5 plus log 3 divided by log 5. Then we examine these two expressions, and you see they are of the form log a divided by log p. By law of logarithm, this will give us log a base p. Therefore, we're going to have 2x is equal to 1 plus, by this law, this becomes log 2 base 5. Then plus, for the same reason, this becomes log 3 base 5. I'm going to now divide both sides by 2. Two cancels 2 here. So we have x is equal to 1 over 2. Then plus, I'll write this as 1 over 2. Log 5 base 2, log 2 base 5. Then plus 1 over 2. Log 3 base 5, giving us the final answer to this problem. And we can now check to confirm that this is correct by substituting the value we just got into the given equation, which was 5 raised to power x times 5 raised to power x is equal to 30. To make this substitution easier, we express this as 5 raised to power 2x is equal to 30, and then we substitute at this point. So we have 5 raised to power 2 into 1 over 2 plus 1 over 2 log 2 base 5 plus 1 over 2 log 3 base 5 to give us 30. I'm going to open this bracket by multiplying everything inside here by 2. Doing that will get rid of these 2's at the denominator, leaving us with 5 raised to power 1 plus log 2 base 5 plus log 3 base 5 to give us 30. Then I need to separate these powers. To do that, I'll use this law of indices. A raised to power m plus n will give us a raised to power m times a raised to power n. So we have 5 raised to power 1 times 5 raised to power log 2 base 5 times 5 raised to power log 3 base 5 to give us 30. 5 raised to power 1 is 5, so we have 5 times every other thing remains the same. Log 2 base 5, 5 raised to power log 3 base 5 to give us 30. Then we look at this expression as well as this expression. They are of the form a raised to power log m base a. And by law of logarithm, this will give us m. So this expression here becomes 2, and this expression here becomes 3. So the whole expression on the left-hand side becomes 5 times 2 times 3 to give us 30. 5 times 2 is 10. Then we have 10 times 3 to give us 30. 10 times 3 is 30 is equal to 30. So the left-hand side gives us the right-hand side, confirming that the solution we just got is perfectly correct. Thanks for watching. Please like and share, and also remember to subscribe to my channel, and I'll see you in my next video.